Excellent. So you may now be wondering what we do if you don't actually have right angled triangles. Well, there's a couple of options. One of them is to turn every triangle into a right angled triangle by sort of chopping it down from the main vertex, but that can be a little bit tricky, and it means that you need to know a few more measurements. However, somebody's already done this algebraically for you, and we've come up with the non-right angled triangle rules. So there are two of them plus an area rule. So there's the sine rule, which we're going to run through today. There is the cosine rule, which we'll run through tomorrow. And then there is the area rule, which allows you to find area of non-right angled triangles really easily. Now, there are some proofs for this. They actually do come from SOHCAHTOA and Pythagoras. And I'm happy to go through that with you if you would like to see them. But otherwise we will just carry on and show you how they work. Okay, the first thing to know about the sine rule is it looks incredibly complicated, and that can be a little bit of a pain. I'm just going to scribble this one out because unfortunately it's managed to morph itself. Okay, so we're going to concentrate on this rule here. Now, one of the unusual things about the sine rule is you may notice it has two equal signs. Okay, what that's telling you is there are three fractions, all of which are equal to each other. However, you only need to use two of them. So if you had side C and side A, you would just use the first two. But if you had B, you might use another combination. So although there's two equals, you only need to use two of the three parts. Now there is another version of this, which I came out very wrongly above. And that is where you turn it upside down, which is a really cool thing to do. So here we go. It also doesn't matter what order these three go in, as long as the C sits with the C, the A sits with the A, and the B sits with the B. Now, if you're wondering which version of these two formulas to use, it's really easy to tell. Can you see on this one that the side is on top? Well, that means if you are looking for a side, okay, and this one has the angle on top, and so you use it when you're looking for an angle. All right, as quick as that. If you use the wrong version, there's not a problem. You won't get a wrong answer, but it's just a little bit harder to manipulate. In other words, you've got to do about 3 algebraic steps to get it right. The best thing is that if you do get it wrong, you can actually just simply flip the whole thing over before you actually try and solve it. All right, so let's have a look at a problem here. We've got a non-right angled triangle. I know that because it's not marked. You can't tell just by looking at them. But this one definitely, there's no indication anywhere. They haven't told you there's a vertical wall. There is no right angle anywhere near it. So therefore, we have to assume that it's a non-right angled triangle. Interestingly, the sine and the cosine rule will work for right angles as well. It'll just be a little, it just takes a little bit longer than SOHCAHTOA. All right, so we're going to work through this problem now and see where we get up to. All right, so what I noticed here, and I'm going to do some labeling here, is that this side here, I'm going to call angle A, which means its little opposite side is little a. And then this side here, I'm going to call little b, because its angle is big B. You'll notice these guys are in pairs. So if you have a look, the side and the angle are always opposite each other. Now, I am looking for a side, so I'm going to use the side version on top. So that means I'm going to have A over sine A equals B over sine B. Now, I don't need the C's because nobody cares about that third set of angles at all, so I don't need to worry about it. So I'm just going to use the first two pieces. Now, if you have a look in my writing here, what I've done is I have moved those pieces in. So I've just labeled it. So I don't know what side A is, but I do know what the angle, so sine of the angle is, sine 38. And then for the other pair, I know what 9.4 is, and I also know that is sine of 68. Okay, now in order to solve this, it looks really complicated. It's really, really easy. I'm going to leave A on its own, and to get the piece underneath up, all I have to do is multiply. Okay, so all I have to do is multiply. You will see that it's written out here really nicely. You can either write it out nicely like this line or the previous line above. It won't matter. Now the cool thing is now is that you've got to run this through your calculator, and you do need to be a little bit careful. Can I suggest you run the top line first and press equals? So what you're on your calculator, so the calculator version, so let me just pop that up here. You're going to run 9.4 times sine 38 and press equals. And then you're going to divide by sine 68. That's just going to stop the calculator trying to do anything silly with bed mass. It should be fine, but sometimes, you know, it just doesn't quite work out that way. All right, so if you run that through your calculator and you're on degrees, you should get 6.2417. And because they asked for 3 significant figures, I've taken 1, 2, 3. The one beside it is not big enough to make that 4 roll over, so therefore it's 6.24 centimeters to 3 significant figures. Excellent. Let's have a look at 2 more problems really quickly. First of all, I've got an angle and a side, so this pair here, and then I have a second one, but I've got a missing side. All right, so I'm going to do exactly the same thing. I'm going to label this A and little a, and I'm going to label this B and little b. I'm going to write the formula out first. I'm looking for a side, so that goes on top. So A over sine big A equals B over sine of big B. Next step is to actually transpose that information in. Okay, so that means I don't know what A is, so I leave that there. I have sine of 42, and that is equal to the other pair, which is 9, the length, over sine of 64. And if I run that through my calculator, I will get an answer. Just got to find my calculator. Hang on a minute. There we go. Now you do need to make sure that your calculator is not on radians, because that will be a problem, and mine is. So I'm just going to go and change that very quickly. Here we go. And if you want to know how to do that fast, you just hit the mode button, and it's just gone dead. So that's really useful. All right. Let me see if I've got a second one in here. I do. One of the problems if you've got the rechargeables is that they do discharge really quickly. So let's just see if I can get this one to work. Oh, battery's low on this one. Let's just see if it'll get me far enough to actually get it working. All right, let's just run down. Excellent. Okay, here we go. So here I'm going to leave the A on this side. I'm going to have the 9. I'm going to have it times sine 42, because remember I multiply that up, and over sine 64. So here we go. So I've got 9 times sine 42. It's really good to press to equals or enter, and then I'm going to divide it by sine of 64, and I've got 6.7. And it's 00, so 6.7 centimeters. They didn't tell me, so I'm going to do that to 2SF. Okay. Question 2 here I'm going to leave for you to have a little go at, and then you can check the answer in with me. All right, so what happens if we're trying to find the size of a marked angle? Okay, so what we're going to do here is you're going to use the formula exactly the same. It's just we'll be filling different pieces in. All right, so this time if you have a look, I've got angle B here, so this is little side B, and I'm going to have side, I'm going to call this C just because I can, so this is little side C and angle C. So this time I'm going to use the 2 pieces that say sine of B over big B equals sine of C over big C. Won't matter what you label it, it's fine like that. What you can see is that I've actually put that into my equation. So if you have a look, here is sine B. I don't know what that angle is. I'm looking for it. Okay, it's over its pair of 8.1. Okay, and then I've got sine of 72 over its friend, which is 9.8. Now the nice thing here is that you're still just going to multiply up. So that 8.1 you're going to see is going to rise up and multiply. So I'm going to do this. All right, so there it is. This time you just run it through your calculator. I apologize, that should be sine of big B. And that's what you get. Now the funny thing here is that you get a decimal, you have to convert it out of the ratio. So that means I'm going to press shift sign. Okay, so when I press shift sign, so that's sine to the -1 of that number. Now don't cut it off. You'll notice there's a whole lot of dots here. Okay, I'm going to put that whole thing in using my answer key. When I do that, it's going to get 51.820. All right, or 51.8 degrees to 1 decimal place. I've got 2 of them for you to stop the slide on and try next, and then you can check out your answers with me before you carry on.